Hey, PlatformCon. Thanks for having us at this year's conference. I hope there's something you can take away from this short talk. So, before we get stuck into the content, I'd like to introduce myself. I'm Jack, a software engineer at Cloudsmith. I've been here for nearly 2 years and I've worked on various areas, including the platform, API, and package implementation, to name but a few. I'm here to tell you a short story about how our artifact management solution sits at the core of our platform engineering operations, how we use ourselves to build ourselves, a bit meta. We'll talk about how we host our internal artifacts or packages, how we consume artifacts, both internal and OSS, and how we get them into production. We'll take a brief look at how we ensure we are license compliant and free from vulnerabilities. Hope you enjoy. So, firstly, what is Cloudsmith? Well, before telling the story, we have to set some context and explain at a high level what problem Cloudsmith is trying to solve. Our sort of catchline is that we are a universal, cloud-native, secure artifact management solution, really a central source of truth for all your artifacts within your builds, whether that be in development or production. If you've ever fetched a font awesome icon, read the Financial Times on a device, or looked up Stack Overflow for a frustrating bug, I know I definitely have, we help those guys keep their pipelines secure, and many more as well. As you can imagine, large enterprise solutions and customers, like the ones I've just mentioned, are pushing and pulling a lot of software. And thanks to Cloudsmith, they don't have to worry about distributing to their developers and or customers. So how do we actually do this? And let's have a quick look at our architecture. So on this slide here, it's really the general architecture for serving synchronous requests. So, and at Cloudsmith, we use AWS. The clients consist of native package managers, so think of tools like pip and npm, and users directly themselves. If they want to download packages or artifacts onto their machines directly, we count them as a client. So this architecture you see here is actually geographically distributed across 4 regions, with each region containing 3 availability zones, really for maximum resiliency and for maximum redundancy. Our customers, we're critical to what our customers are doing. So we need to be up and we need to be serving packages at all times. So let's talk about what actually happens when, for example, a client requests an artifact from Cloudsmith. Well, the first thing that happen is the client is actually routed to the nearest CDN location, utilizing the 600 points of presence across 47 different countries that CloudFront can provide for us. It's really the first point of contact for our customers and enables super fast content delivery. Like I just said, this is utilizing CloudFront on AWS. The next step then is the load balancer. And what this does, essentially, it takes the incoming requests and ultimately just distributes them fairly to the backend servers. We utilize AWS Elastic Load Balancer with the target groups set ultimately to ECS server tasks. And I'll come back to this and talk a bit more about this in a couple of seconds. The request then hits our reverse proxies. It'll pass through Nginx for header and request manipulation and some protection too, and HA proxy for request queuing. This is helpful, in times of really high load and we need to queue requests momentarily. The web nodes are actually Django applications, and this is ultimately where the business logic is predominantly computed. Here, the request interacts with our caching layer. So our caching is predominantly Memcache, and the database, which is Postgres on RDS. And object storage too, we use S3. We ultimately use S3 for storing the artifacts, binaries and source packages themselves, and it's worked really well for us. For asynchronous processing, we use Celery, and Celery is basically a task queue, for real-time processing and task scheduling, stuff you want to do out of bounds of a direct synchronous request. These asynchronous tasks are ultimately computed on worker nodes with messages sent and consumed via a RabbitMQ deployment. And here we utilize Amazon MQ. For simplicity in this diagram, I've encapsulated the web and worker nodes within the web app and server box, but ultimately these are deployed as an ECS cluster, which contains distinct services for asynchronous processing and synchronous processing, like this diagram shows. Within ECS itself, we use the Fargate launch type. So the app is ultimately packaged into containers. This enables quick and easy scaling when we need it. So far, it's worked pretty well for us here at Cloudsmith. So this architecture here, how do we keep it up to date? Well, day-to-day deployments typically involve keeping the Django application up to date. So that's ultimately the thing that changes, and what the customers see. We make a change to the business logic, it's predominantly in the Django application. And to do this, we have an internal developer CLI tool called COps, and that intuitively stands for Cloudsmith Operation. And that's what manages these deployments. At a very high level, we could go into lots of details of what's actually going on here, but not a need for this talk. The tool essentially kicks off Circle CI workflows, and behind the scenes, ECS task definitions are deregistered and new ones registered, the new ones that we manipulate during the deployment workflow. The service is then ultimately appointed to use the new task definitions, with AWS handling the rolling update on our behalf. So let's take a closer look at actually our environments here. So what we have here is essentially like typical you'd see in a lot of software companies. You have your development environment, you have your staging environment, and then ultimately your production environment as well. But the key thing to note here is meta. And when we say meta, we mean like Cloudsmith's own deployed version of Cloudsmith. And this is ultimately where we use ourselves. It's used extensively for consuming things that we have pushed to this environment ourselves. For example, the Docker base image, what the Django application itself actually runs on top of, and OSS packages, which ultimately come from upstreams. So, we're Django applications, so we're pulling a lot of Python libraries in. And then other things like, we've got a Debian upstream as well. So for building the Docker base images. The key thing to note here is that all internal and OSS packages are obviously transparently pulled through our version of Cloudsmith. And what we find really useful is that they undergo vulnerability and license checks. So any checks that are flagged, any checks that fail, they're actually flagged to us and prevented from entering our builds. This is really important, and it gives us a peace of mind that we're not bringing in vulnerable artifacts into our builds, which ultimately then pass on through to production. The artifacts are ultimately pulled when developers across the business are spinning up their local development environments. Like I've said, those Python dependencies and Docker images. Some other examples of Docker images were pulled are, format specific images, for performing tasks, out of bounds of the actual main Django application. So you can see how it's used in development environment, and then I'll talk about how it's used in the release here. I've listed here the Circle CI runner job, and it consumes as well from our own deployed meta. And we'll talk about a bit about that briefly. Key thing, I guess, to note here is, when changes have been approved, in PRs and are ready for release, a new version number is generated. A Docker image is pretty much built and packaged, ready to be promoted across the environments. So let's take a look at the next slide. So really, what makes up a release? And the key thing sort of to note here is that the Django app is generally what we're updating to get visible changes in front of customers. And let's have a wee quick look inside. I've pretty much covered everything I'm going to say here, but it's pretty much the base image. It's pulling from our own deployed Cloudsmith meta. And that's an image that we have built, ourselves, and we store it on meta. And that contains really the OS level dependencies of runtimes, Node, Python, for really executing the business logic on top of other things. Like I've said, the Python dependencies and JavaScript dependencies, things for the front end. And ultimately on top of that sits the Cloudsmith code, ultimately the business logic. And that's essentially what encapsulates a Cloudsmith release. Here I've called it Cloudsmith release version 1.00. It's a lot more versions than that now. So our role in our releases, Cloudsmith's role in Cloudsmith releases, that's a bit of a mouthful to say. It's really two main critical areas. And the first is after merging domain. I mentioned there previously, you've got developers are ready to go and they want to ship the software that they've built. So really, once that happens, then a commit workflow is kicked off using in Circle CI. That's the CI/CD tool that we ultimately use. And here it pulls essential images from Cloudsmith to run jobs on top of. Generally, these images have been built and pushed by us. So here's an example on the left here of some of the examples of the jobs we have. Things like PyLint, for checking that our code looks pretty, essentially, and PyTest as well, for running all our Python test suites. Some other things as well, like pre-commit and license check and some migration check as well. But the key thing to note here is that ultimately it's pulling the Docker base image to execute these jobs on top of. The next critical area is the end-to-end testing workflow. And that's what I've sort of demonstrated on the right here. Really, after the rolling update has been completed and the environment is using the latest release, an end-to-end workflow is kicked off. These check that all variations of supported formats are still working. So as these are native format-specific tests, they require appropriate images or runtimes in order to execute. Again, pretty much like the commit workflow, these are pulled into the Circle CI runner. In this case, the runner is the end-to-end workflow from Meta. So, and again, Meta, just to be clear, is our own deployed version of Cloudsmith. And again, all these images we know are free from vulnerabilities. They're license compliant. And all that good stuff. So some examples here, in the end-to-end workflow is like npm test. So we'll need to execute on top of a Node image, Python test, and a Python image. They'll be executed upon. So just for context, I think it's something like over 100 end-to-end tests are executed every time an environment is deployed to staging and production. It happens for staging and production. So we know that all our formats are still working as should be. And that's really it. So just to conclude, I hope I've got across the point that shows that how Cloudsmith serves as the backbone of our platform engineering, how we use ourselves to build ourselves, and really facilitating the seamless artifact management from development right through to production. I hope I've demonstrated that by leveraging Cloudsmith actually internally, we ensure robustness and security, hopefully embodying the reliability we offer to our customers. And that's really it. Thanks very much for listening. If you've got any questions, feel free to reach out to me or grab me at the live time. Thanks, guys.